Here we're proving trig identities using conjugates. When you look at the left-hand side of the equation compared to the right-hand side of the equation, you can see that neither side is messier than the other. So if I choose to work with the left-hand side of the equation, which is sine x over 1 minus cosine x, in order for me to separate this out into two fractions, the denominator has to be a single term. So if we look to get it to be a single term, we can do so by multiplying it by its conjugate, which is 1 plus cosine x. They look the same, but their signs in the middle are opposites of each other. If I multiply the denominator, that means I also have to multiply the numerator. Okay, well, when you multiply the denominator, 1 plus cosine x times 1 minus cosine x, you're going to get 1 minus cosine x plus cosine x minus cosine squared x. And for now, in the numerator, we're just going to go ahead and leave that as 1 plus cosine x times sine x. You can see in the denominator the negative cosine x and the positive cosine x are going to cancel each other out. So here we're left with 1 plus cosine x times the quantity sine x all over 1 minus cosine squared x. Now I said we needed to get it to be a single term. So if we think about our Pythagorean identity, the Pythagorean identity says we have sine squared x plus cosine squared x, and that's equal to 1. If you look at the denominator says 1 minus cosine squared x. So if we go back to our Pythagorean identity and you subtract cosine squared x from both sides, then here we're going to be left with sine squared x is equal to 1 minus cosine squared x, which is going to allow me to replace 1 minus cosine squared x with sine squared x in the denominator. So the numerator is going to stay 1 plus cosine x over times sine x over, now we're replacing this with sine squared x. If you look back at the right-hand side of the equation, which says 1 plus cosine x over sine x, you can see that from the numerator to the denominator, I can eliminate 1 sine x, which says that in the end I'm going to be left with 1 plus cosine x over sine x, which is what we were trying to prove in our beginning equation.